All right, so number 6. There we go. All right. The function f is continuous on the closed interval -3 to 3, such that f of -3 is 4 and f of 3 is 1. Okay, so there we're given some points on f. The functions f prime and f double prime have the properties given in the table below. So we're not given a graph in this case, we are given a table. Slightly different than what we've been looking at so far, but we can still use this information. Okay, so again, the function is continuous on this interval, and we have these 2 points on our original function. And then we have f prime and f double prime with these properties. Okay, so if we'll kind of read through this here. So we've got some intervals, right? There's 3 intervals there from -3 all the way up to then 3. And we can also have some values at specific points too, so x equals -1, x equals 1. And then we have signs. So for example, at f prime of x on this interval is positive, then it changes to negative, then it changes to negative. F double prime on this interval is positive, then it changes to positive, stays positive I should say, and then it changes to negative. And then we have some specific values of at x equals -1 and x equals 1 as well. So, letter A says, at what value of x does f attain its relative minimum and maximum value, if any? So it may not attain a relative minimum or maximum here. So let's go to, all right, Joey. So if we want to find a relative minimum of f, what are we looking for? Or what do we want to look at? Okay, so we want to look at f prime, and then we want to do what? Once we have f prime,
we want to figure out where it comes from, a negative and a positive.
Where f prime changes from negative to positive, we normally first figure out when f prime is equal to 0, and it looks like f prime equals 0 at 1, but also it's undefined at -1. So both of these are basically like critical points, you could say then, right?
Yeah.
Okay, and so then does our derivative, does f prime change from negative to positive? No, okay? So, f does not have a relative minimum because, and what we say here, f prime what?
Doesn't ever change from positive to negative.
Yeah, because f prime does not change from negative to positive. Does not change from negative to positive. Does not change from negative to positive.
We need to explicitly state that it does not have a relative minimum.
I think so. Yes, I think so in this case, yes. Because it says at what f, if any, so I want to state that just to be, very explicit about it. You're right, maybe it's not as clear whether we have to state it or not, but I think it's a good idea to state it. So f does not have a relative minimum because f prime does not change from negative to positive on, and I'm going to say the interval -3 to 3. Okay, so thank you, Joey. Very good. Mac, does f have a relative maximum? So, to determine if f has a relative maximum, we look at what?
Well, you could look at f prime.
F prime. That's right. Okay, and we decide if we have any critical points. And we do have critical points, right? At -1 and 1, the derivative is either undefined or 0. So those are our critical points, okay? And then we want to see if the derivative is changing from what to what for a relative maximum.
Positive to negative.
Right, okay, so does the derivative ever change from positive to negative at one of those critical points?
Yes.
Yes, at which one? Okay, hang on a second. F has a relative maximum at x equals, okay, so you want to say it changes at 0?
Well, am I looking at the top part of the chart?
Yeah, you're using the table here, and yes, we want to use the top row because that's f prime.
Yeah, I got that part.
Okay, so we can see that it changes in this interval, it's positive, and then it changes to negative, but at what point is it switching exactly? Where do you get 2 from?
Because it's in between.
In between what?
3 and 1.
So careful, it's -3 and -1.
So -2.
And then it switches over from the interval from -1 to 1. So what number is between the interval -3 to -1 and -1 to 1? What kind of like joins those two things together?
Not zero.
Yeah, not zero. Zero's outside this interval. What number joins these two intervals together? This one ends at -1. This one starts at -1. Yeah, it's at -1. This point right here. This is so basically this is like your number line. You can kind of think of this is like our number line here in so much work. Okay, -1 is our point, and then 1 is our point. We're told it's positive, then negative, and then negative. That's what this basically is right here. And so yes, f has a relative maximum at x equals -1 because, and what was our reasoning again, Mac, that we said that f prime what? Yes. Positive to negative at that point.
Did you want x equals 3 for the relative, or for the absolute minimum? Yeah.
Okay, great. Questions on A? We're all good with that? All right, so letter B. At what value of x does f attain its absolute minimum value and absolute maximum value on the interval from -3 less than or equal to x less than or equal to 3? Show the analysis that leads to your answer. All right, so first of all, what are our candidates, Connor, for the absolute extrema here? Critical points. So in this particular case, what are those numbers that are our critical points? Okay, so -3 and 3. That's the endpoints of the intervals. That's some of the candidates. Yep. So we want to consider that. And then what other points do we need to consider? You said the critical points. What are the critical points of f here? Or actually, yeah, we get them using f prime. So what are the critical points according to f prime? That's one of them. How do you know that's a critical point? Because the derivative is what? That doesn't make a critical point. When I want to find critical points, Connor, if I just tell you, here's the function, Connor, find the critical points, what do you do? Set what equal to 0? Right, and so when is f prime equal to 0? According to this table. F prime is equal to 0. What's the x value there? When yeah, 0, 1, exactly right. Or when the derivative is what? Not only when it's 0, but also when it's what? Undefined. So -1 and 1, exactly right. So those 4 points, -3, -1, 1, and 3, those are our potential absolute minimums and absolute maximums. Okay, so let's see here. So at -3, our derivative is positive then until we get to -1. So since our derivative is positive, that means the function will be what there, Connor?
Above the x-axis.
Okay, which means, well, no, the derivative will be above the x-axis. Our function will be what?
Positive slope.
Okay, which means it is increasing. Okay, so that means which one's going to be higher, -3 or -1? Yeah, -1 will be because we increase from there to there. And then, so right now, -1 looks like it's the highest point, right? But then we go to this interval, and our derivative is negative in that interval. So then, what does that mean? Our function will be decreasing. So what's going to be higher, -1 or the 1? -1 still, right? And then the next interval, from 1 to 3, the derivative is negative. So therefore, the function will be decreasing. And so again, -1 still got to be the highest point. Okay? So, that's what we're going to say. The absolute maximum of f occurs at x equals -1 because f prime, I'm just going to put this here, f prime is greater than 0 for -3 less than x less than -1. So I'm going to kind of use some symbols here, just kind of make things a little bit easier for me. So absolute maximum of f occurs at x equals -1 because f prime is greater than 0 for -3 less than x less than -1, and f prime is less than 0, that means it's negative, right, for -1 less than x less than 1, and 1 less than x less than 3. Okay, I think that should be sufficient. So basically that just means to the left of -1, the function is increasing, to the right of -1, the function is decreasing, and so therefore -1 has to be the highest point. Okay. Okay, that looks like I got a 4 there for a second, so I put it like 1. All right, now how about the absolute minimum value then? So let's see here. Tyler, what do you think here? What's that? You say at 3. Okay, so why do you say at 3? Okay, so -3 is higher. Okay, Oh, sorry, from -3 to -1. So -1 is going to be higher at least. Okay.
And then from -1 to 1 it goes down.
Uh-huh.
And then from 1 to 3 it goes down.
It goes down even more. Now the only possible question mark there though is that if we started at -3, if we started at a lower value, because right at -3 we increased up to -1, so certainly -3 is lower, right? And then from -1 we decrease and decrease, and so it's either got to be at -3 or at 3 to be the highest one there, right? But what do the directions say? F of -3 is 4, f of 3 is 1, and so you were right. 3 is the absolute lowest point, because f of 3 is 1, whereas f of -3 is 4. Okay, so that's the idea there. So the absolute minimum of f occurs at x equals 3 because okay, f of 3, I'm going to go ahead and say is less than f of -3. Okay, so I'm going to go ahead and just state that f of 3 is less than f of -3, right? It's smaller, so that's got to be it's it throws out that -3 is a possibility. Let's see here. X equals -1 is the absolute maximum. We just said that, so it can't be x equals -1. And lastly, at x equals 1, f prime is less than 0 from -1 less than x, or sorry, positive 1, not -1 there. Positive 1 less than x less than 3. Okay. So basically we just kind of eliminated the other ones. It has to be 3 because f of 3 is less than f of -3 by what we can see right there. X equals -1 is the absolute maximum, so it can't be there. And at x equals 1, the derivative is negative from 1 to 3, so it's going to be decreasing to that 3. So that makes 3 the smallest point. Okay. All right. Letter C, find the x-coordinate of each point of inflection of the graph of f. Justify your answer. Okay, so thank you, T-Rock there. Let's go to Christian. Christian, how do we find points of inflection of f? What do we look at?
Second derivative.
Second derivative, and what do we do with that second derivative once we take it?
Whenever it's switching from negative to positive.
Okay, very good. So let's look at our table there, Christian. Do we have any points of inflection of f?
X equals 1.
Okay, f has a point of inflection. This is why it's so important to know those fundamentals, folks. Okay, Christian was guided right by what we're supposed to do. Okay, so set the derivative equal to 0. Find when its second derivative changes from positive to negative or negative to positive. So f has a point of inflection at x equals 1 because, and what's our argument there?
The second derivative
Yep.
is changing from positive to negative.
Yep, because f prime prime changes from positive to negative at this point. Super straightforward. Okay? We're all okay with that? So just stating that the second derivative equals 0 at that point is not enough information, because if the concavity is not changing, then it doesn't matter that it equals 0. When you set the second derivative equal to 0, that's a possible point of inflection. You still have to do the number line thing, right, Emma, and see if it changes to plus or minus, minus to plus. That's what we did right there by saying it changed from positive to negative. Okay. So good thinking, but right, we got to take that one more step. All right, now we want to sketch a possible graph of f. Okay, so we want to sketch this. Well, what points do we know have to be on f? Okay, so we have to have x values of -1 and 1. Okay, what points though must be on our graph? -3, 4, and 3, 1. So I'm going to go ahead and kind of like. Yeah, I am literally sketching this. Literally. Yes, sorry. And again, we'll plot the points we know. So we know that -3, 4 is going to be a point, and that's not really drawn that well to scale, but okay, that's okay. 3, 1 is going to be a point. Okay, and f is continuous, which means that we need to connect the dots. All right. Now, our table further divides up the interval from -3 to 3, right? How does it divide up the interval? -3 to -1. So between -3 and -1, between these two values right here, right? There's -3, -2, -1. Between these two values, what is our derivative telling us must be happening?
The slope must be positive.
Okay, derivative's positive, therefore the function should be increasing. And what's our second derivative telling us? It's going to be increasing concave up from -3 to -1. Oh, Mr. Widmeyer. All right, so increasing concave up. So that means something like that. Okay, increasing concave up, right? Cup-like, but increasing. So that means it's increasingly increasing, right? And then, yeah, at -1, the derivative fails to exist. Well, what kind of, like, visually do we see? A point, right? So we're going to make this pointy, so that kind of makes sense the way it is right there. It's starting to, like, kind of be pointy. All right, and then from -1 to 1 is our next interval there. And what's our derivative telling us to do? It should be decreasing concave up. So we're going to make, like, a little pointy hat-looking thing. Okay, something like that. At 1, the slope needs to be 0. So notice I kind of like bottom out my slope there too, okay? At 1, my slope needs to be 0, so I kind of bottomed out the slope a little bit at 1. All right, and then the interval from 1 to 3. What's our first derivative tell us? Decreasing and concave down. So decreasing means I need to be going down, but concave down means to be a frown like, so like something like that. Voila. Okay, this is something you should be able to do, okay, for a testing situation. Okay, questions on any of that? Questions on any of that? We're all good? All right, moving on. Number 7 then. Last one. I'll give you guys your assignment. No, number 7, we have one more, and then I'll give you homework.
You don't have to give us homework.
Number 7 is, it's on a page of its own, Mac. So this is what it looks like. All right, so again, let's read through this here real quick. We've got a graph of f prime of x. Note, this is the graph of the derivative of f, not the graph of f. So it's like very highlighting it for us here. F prime, not f, it's f prime. Okay. Or it's a graph of derivative of f, not f itself. Okay, the figure above shows the graph of f prime. Third time it says that to us. The derivative of a function f. The domain of f is the set of all real numbers x such that -3 less than x less than 5. So we're only looking at f, considering f between -3 and 5, and clearly here we see the derivative here also between -3 and 5. Okay. So let's go to someone who's here. So Donovan, letter A says, for what values of x does f have a relative maximum and why? Okay, so you're saying f has a relative maximum at x equals 4. And what's our reasoning going to be there, Donovan? Because why? Okay, so if f prime is changing from negative to positive, that means f is changing from. Yes, it's actually at x equals -2. Very good. Yep, we have to fix that, but that's okay. We have a relative maximum at x equals -2 because, and now what's our justification for that? Why'd you fix that? Because f prime is what? Yes, very good. Good catch, Donovan. Right? That's real, right? Sometimes we get into the problem, we look at it and we're like, oh, it's at 4. And then you're like, wait a minute, it's changing from negative to positive there. That means the function will be changing from decreasing to increasing. That'd be a relative minimum, not a maximum. That's what we want here. So make sure you're answering the question. So good job there, Donovan. Very good. Is that the only relative maximum that we have there, Donovan? Yes, that's the only place where the derivative is changing from positive to negative. So you got it. Good job. Okay. All right, let's go to Ryan for letter B. Sorry, go ahead.
X equals 4.
F has a relative minimum. Okay.
Because f prime changes from negative to positive.
Because f prime is changing from negative to positive at that point. Perfect. Is that the only relative minimum that we have here, Ryan?
Yes.
Yes. That is correct. Great. Okay. Yep. All right, so letter C says, on what intervals is the graph of f concave upward? Use f prime to justify your answer. All right, so this one's a little bit trickier, right? Because now we're using f prime to talk about f double prime to then talk about f. Okay, so it's like an extra step is added in there. So Drew, what are you thinking here? On what intervals is the graph of f going to be concave upward? Okay. And what else do you want to say? Okay, I know it's pretty complicated. May I help? So, all right, so you want to know when f is concave upward. What do we use to determine concavity of f? Like, what do we look at? The second derivative. That's right. Specifically for concave upward, we want to know when the second derivative is... just for concave upward. So we want to know when the second derivative, not changing. Just when the second derivative is what? 0 would not indicate concave upward. That's where a possible point of inflection is. For concave up, right, that's like an interval. We want to know when the second derivative is what? Positive. It's when the second derivative is positive, right? And if we want to know concave down, that's when the second derivative is negative, and then for point of inflection, that's where the second derivative changes from positive to negative or negative to positive because the concavity is changing. So the concavity of using the second derivative is just like increasing and decreasing for the first derivative. Where the first derivative is positive, the function's increasing. Where the second derivative, or where the first derivative is negative, the original function's decreasing. Concavity is determined by the second derivative. Okay, so back to that. We want to know then, when is f prime prime positive? Okay? F prime prime is also the derivative of f prime. So if f prime prime is positive, what kind of behavior should we be seeing in f prime? F prime should be, yes, increasing. You got it. So what are the intervals where f prime is increasing? Yep. And then 3 to 5, yes. Say that one more time, Brittany. Like 5 is 5 an endpoint? Yes, we're only considering, if you look here, the domain of f is the set of all real numbers x such that -3 less than, so we're only going up to 5. So -1 to 1, union 3 to 5 is the interval where f is concave up because f prime is increasing. That's all we had to look for. You don't have to say anything about f double prime or anything like that. Just saying on that intervals. Okay? It gets tougher because there's like 2 steps now to think about, 2 kind of translations you have to make, so it makes it a little bit trickier. Okay, but that's the idea. Does that make sense there? Okay? That one's a little bit trickier. Alright, letter D. Given f of 1 is equal to pi, and g of x is equal to -2e to the f of x, write the equation of the tangent line to g at x equals 1. Okay, so again, we have to break down what do we need to write the equation of a tangent line. I'm going to go to... Oh, keeps going to Caleb and he's not here. Let's go to someone. So Jack, what do we need to write the equation of a tangent line? You need the derivative. Okay, so we want to write the tangent line to g, so I'm going to take the derivative of g. So g prime of x is going to equal, well, if g is equal to -2e to the f of x, what would g prime be there, Jack? Okay, careful. When we do the derivative of e to the something, we don't bring that something out front, right? What's the derivative of e to the something?
So it would just be -2e to f
Times f prime of x. Very good, the derivative. Excellent. Okay? So we have the derivative. What are we going to use the derivative to find about our tangent line, Jack? What does the derivative tell us about our tangent line? Emma? The slope. The slope of the tangent line, right? Okay, so Tyler, quick. Yep. Okay, but be careful. It's the line tangent to G, not the line tangent to F prime. So you look at the graph of F prime, yes, it would be a slope of 0, but we're looking at G, so that's the function unto itself. It has F in it, so we're going to use that function in the graph and stuff, but so good thinking, but yeah, make sure you're finding the tangent line to the question we want. So, G prime of what in this case, Jack? Yeah, at 1. We're going to find G prime at 1. So G prime of 1 equals -2e to the f of 1 times f prime of 1. Okay. What's f of 1, Jack? Yep, so it's going to be -2e to the pi. Word, all right. So, and then f prime of 1, what's that? 0. So our slope is 0. Okay, easy enough. And then we also need to find, so we have the slope of our tangent line. Now what do we need? To write the equation of a line, you need the slope and a, yeah, or a point even, yeah. So all we have is that we have the x-coordinate of 1. How can I find its matching y-coordinate? Again, we want it to be tangent to G, so 1 we're going to plug into G. Yeah, so we're going to do G of 1, which is equal to -2e to the f of 1. All right, what's f of 1, Jack? Pi. So -2e to the pi. All right, so we have the point 1 comma -2e to the pi, and we have the slope of 0. So our equation is y minus -2e to the pi, which is the same thing as plus positive e to the 2 pi, equals 0 times x minus 1. Or you could just say y equals what? -2e to the pi. That's the equation of our line. One of those two is fine. Okay, if you simplified it would just be that, though. Okay? So again, Don't freak out that we got some like weird functions here. We're trying to write the equation of the tangent line to that weird function. Use what you know. The fundamentals, you have to know those. When I say, what do we need to write the equation of a tangent line, you should immediately think slope and a point. How do you find the slope of a tangent line? Take the derivative of the function. How do you find the point? Plug your x back into the original function. Stuff like that. It should be very, like bing, 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 bang, boom. Okay? And then you can leave your brain there to figure out the other important stuff that you need to be able to do. How to take the derivative and all that. Okay? Questions on D? What would that look like? It'd be a flat horizontal line.
Okay, I can't find them.
So yeah, it would be a flat horizontal line. I'll just graph it here for you real quick. So negative 2e to the pi. Probably because it's off my window. If I go down to like negative, let me go down to negative 20. Oh shoot, I always do that. Alright, so we got negative 2e to the pi. Oh, it's negative 46. So, there it is. Just a horizontal line. Because it's y equal, what is negative 2e to the pi? Just a constant. So it's y equals a number. That's a horizontal line. What's that? Oh, okay. So letter E, given G as defined above, for what values of x does G have a relative maximum? Justify your answer. Ooh, okay. So now we're not looking for the relative maximum of f. We're looking to use G. So, again, okay, let's see here. So, Chanda, how do we find a relative maximum of a function? What do we do with that function? Okay, great. So we want to find the relative maximum of G, so we got to look at its derivative, which is, well, there's G, and we just found its derivative right here. So G prime of x is equal to negative 2 e to the f of x times f prime of x. All right, and we got to find this thing's critical points. So that means we want to know when this thing is equal to what? 0 or undefined. All right, so let's do the first part here. Let's set it equal to 0. Ooh, this is a mess. But it's being multiplied, so I can break it up and say that f prime of x equals 0. And I can say that negative 2e to the f of x equals 0. Okay? Chanda, when does f prime of x equal 0? Well, let's go back up here to the top. Isn't this a graph of f prime of x? Where does it equal 0? At negative 2, 1, and 4. Yeah, so... and then when will this equal 0? Never. Right. We have e being raised to a power. That's going to be positive, but then it'll be times negative 2, so it'll be overall negative. That never equals 0, so we can just ignore that. So there are critical points, and so guess what? We can make a little number line here. Oh, sorry, not f prime. We're looking at g prime here. Okay, so we'll put in negative 2, 1, and 4. All right, so let's evaluate g prime of negative 3. Let's try g prime of 0. Let's try g prime of 2, and let's try g prime of 5. I picked your numbers for you there, Chanda, but I know you're not going to be insulted by that. Okay. Or you might be, and I apologize. All right. So here, g prime of negative 3. Well, that's going to be this guy right here, right? All right. This thing will always be what? Regardless of what we plug in, it's always going to be what value? Negative or positive? It's always going to be negative. So g prime of negative 3, this piece will be negative. And then what's f prime of negative 3? It's positive. How do you know? Yeah, the graph. Look at the graph here, folks. At negative 3, f prime is a positive value. It's above the x-axis. So overall, this interval is negative, though. All right, what about a g prime of 0? So again, plugging in 0 is going to be negative first. And then what's f prime of 0? Negative, so negative times negative, positive overall. G prime of 2. Again, it's going to be negative from the negative 2e to the f of x. And then what's f prime of 2? Negative, so overall it's positive. And then g prime of 5, again, that's going to be negative for the first thing. And then f prime of 5, positive. So negative times a positive is a negative. Wow, so we did all that work without having to do very much math, okay, like actual computations, just using what we know. Okay, great. So Chanda, does G have a relative maximum? Okay, G has a relative maximum at what? Maximum at x equals 4, because G prime, what? Changes from, careful, positive to negative, yeah. At x equals 4. And that's sufficient. Boom, there it is.
Ta-da.
Whoop, there it is.
There it is.
All right, question.